Okay, section 2.3, we are looking at measures of locations. We have percentiles. So if I'm looking at a percentile, that is telling me that an observation, that some percent of observations are falling below it. To find a percentile, the data must be ranked. Okay, so let's say you are looking at a college admissions letter or their requirements, and they say that you need to score in the 90th percentile on your SATs in order to be admitted. What that means is that you need to score better than 90% of students that are taking it. So that's what the percentile is. Everything else in that percentile is below on your ranking. So 90 percentile would mean that you're scoring higher than 90% of people, or you could look at it from the opposite end of the spectrum, that you're in the top 10%. Okay, quartiles. So quartiles would be taking a group of data and separating it into quartiles. So the first quartile is going to be the 25th percentile of data, which means 25% of data are going to lie below that data value. The second quartile is the 50th percentile. So 50% of data will lie below it. This is also the median. Okay, the median is quartile 2. Quartile 3, that is the third quartile, that is the 75th percentile. 75% of data lie below that value. The interquartile range is going to be the middle 50% of data, which is quartile 3 minus quartile 1. Okay, so the interquartile range is the middle 50%. Okay, we are going to look how to plot this on a graph, just kind of looking ahead before we do that. It is going to look something like this. So if I had a perfect piece of data, right? This is called a box plot. The middle 50% is going to be right here. Okay, here's the bottom 25%. This would be the middle 50%. This would be the top 25%. Okay, that is how we would graph this, or how we're looking at this in the data. Okay, now before we do that, let's look at finding some other percentiles besides these. So you could find any percentile. You could find the 37th percentile. You could find the 99th. Okay, that is going to be here. So quartiles and percentiles may or may not be observations in an actual data set. Okay, sometimes a quartile or a percent might fall between two observations. So we might say the 99th percentile would be a 1600 on the SAT, but in the data set that I'm looking at, I don't have anybody with that. That's okay. All right, it's just a percentile desired here. So here's the formula. You have K is going to be the percentile desired. I is going to be the index. N is the total number of data. So we're going to first put the data in order, and then we're going to go I equals K over 100, and then N plus 1. If I is a whole number, then the kth percentile is the data value in that position in the ordered set of data. And then if it is not a whole number, we're going to round it up and down and then take the mean average. Okay, so calculate the 25th and 90th percentiles of the data set shown below. All right, so first of all, we need to put this in order. So let me see here. We have 3, then 5, 6, then 12, 22, 25, 27, and 30. All right, let me kind of put lines in between them. Okay, so first we want to find the 25th percentile. So that's going to be K. So K is going to be 25. All right. I is going to be where that is in the data set. N is the total number of data. So 1, 2, 3, 4, 5, 6, 7, 8. So N is going to be 8. All right, so we're going to go I equals K over 100, and then times N plus 1. So 25 divided by 100 times 9. So that is going to be 2.25. Okay, I is the position, okay? So 2.25, this is not a whole number, so we're going to look at this situation right here. We're going to round I up and round I down, and then we're going to take the mean average of these two values. Okay, so that means that this is going to be 2 and 3. So that means I'm going to take the second and third number in my data set. So the second and third number are these values right here. Okay, so I'm going to take 5 and 6, and I'm going to find the mean average of those, which is just 5.5. Okay, so 5 plus 6 divided by 2 would be 5.5. So that means that the 25th percentile is the value 5.5. That's not actually in the data set. Okay, but that is the 25th percentile. So let's say these are, what could this be realistically? This would not be test scores. Maybe these are number of credit hours. We'll see. Yeah, number of credit hours that we're taking. To be in the 25th percentile of students taking credit hours, you would have to take 5.5 or right around there. So 6 credit hours would be technically like 26th or 27th percentile, something along those lines. Okay, and then anything below that, or if you're taking 5.5 credit hours, then 25% of students are taking fewer than that. 75% are taking more. Let's do the 90th percentile. So we're going to do this again with the 90th. So here we'll do a K of 90. Let me go over here. N is still going to be 8. So we're going to go I. It's going to be 90 over 100 times 8 plus 1. So let's see what that gives us. And then that's going to be times 9. So I put 9 over 100, sorry, 90 over 100. There we go. Times 9. That's going to be 8.1. Okay, so you want the 8th and 9th value in the data set. There's only 8 values in the data set. So in this case, you would just take the 30. Okay, 1, 2, 3, 4, 5, 6, 7, 8. There's no 9th value there. So the 90th percentile in this case would be 30 or more credit hours because you don't have anything to add that to and find a another value. Okay, now percentile rank. So now this is going opposite. So this is finding, okay, what the 25th and 90th percentile is. Now percentile rank is, okay, the number 22, what is that percentile? Okay, so now this here. Here is what we're going to do. So you're going to rank the data. So you want to put it in order. X is going to be the number of values less than A, so whatever we're doing it. And then Y is the frequency. So how many times does that number occur? And then here's our formula. Okay, so here, the data below give the amount of money. spent on fast food by 16 individuals over a 1-week period. Calculate the percentile rank of 26 and 51. Round the solutions to 1 decimal place if necessary. Okay, so I need to put this in order first. So let me see here. My smallest, I think, is 13. So 13. Then I have a 14. Let's see, there's 17. Yeah, 17 is next. 23. 26. 36, no, another 26. 35. 36. Another 36. Let's see, 47. And then 51. 4 of them. Then 53, 55. Okay, so this is in order. Okay, so percentile rank of 26. So we're going to find the number 26. Here it is, twice, right here. Okay, how many values are less than that? So 1, 2, 3, 4. So x is going to be 4. Okay, there's 4 values less than the number 26. How many times does 26 happen? 2 times. So y is going to be 2. Okay, and then n is how many there are. So I think it was 16. Yeah, there's 16 here. And then we're going to put that in. So a is going to equal x. So 4 plus 0.5 times 2 over n, which is 16. And then we're going to times that by 100, and that's going to give us a percent. Okay, so let's go ahead and do that. So we've got 4 plus 0.5 times 2 divided by 16 times 100. So that will give us 31.25. And at 31.25%, we want to do 1 decimal place, so that would be 31.3%. So 26, so if you spent $26 on fast food, you're in the 31.3 percentile. So you spent more money than 31% of people. Then about 69% of people spent more money than you. Okay, then 51, we'll do the same thing. So for 51, let's see here, how many values are less than that? So here's 51. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values less than that, so that's your x. 51 occurs 4 times and is still 16. So there we're going to go, let's see here, 10, so x plus 0.5 times 4 over 16 times 100. Okay, so 10 plus 0.5 times 4, 12 divided by 16, 0.75 times 100, 75. So that percentile is 75. So if you spend $51 in a week on fast food, you are in the 75th percentile of data, or of people buying fast food. All right, let's do another example where we're going to find a lot of different things. All right, the data set below is composed of the salaries of all 11 employees at a small company. So first of all 11 employees, that is a population, just in case we need that for later. I'm going to start noting those things. Are they in order? No. All right, we need to put these in order. So let's see here, 2,000. Then we've got 28,000. Let's see here, 28,033. 40,500. 42,000. 54 twice. And then let's see, 54. Then we have 64,500. 68,500. 69,000. And then 120. Okay, we want quartile 1, quartile 2, and quartile 3. Okay, so let's find those. So quartile 1 is going to be the 25th percentile. Quartile 2 is the median. Quartile 3 is the 75th percentile. Easy way to do this is, let's see here, we count these values. So let's find quartile 2 first. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if there's 11 values, then we've got to go 11 divided by 2, 5.5. So 1, 2, 3, 4, 5.5. 1, 2, 3, 4, 5. So there's 5 values on either side of the 54,000. Okay, so that's going to be your quartile 2 or your median. Quartile 1 then is the median of the lower half of data. So if I'm looking at these 5 pieces of data here, here's the median. That's quartile 1. And then quartile 3 is the median of the upper half of the data. So that's right here, quartile 3. Okay, so we've got quartile 1, quartile 2, quartile 3. So that's the first part. Interquartile range. Interquartile range is quartile 3 minus quartile 1. Okay, quartile 3 is 68,500. Quartile 1, 33,000. That is going to give me 35,500. Okay, the middle 50% of data, the interquartile range, has a range of 35,500, a spread, if you will. 70th percentile and 35th percentile. Okay, so 70th percentile, we're going to use for percentiles, you're using I equals K over 100 times N plus 1. Okay, so for 70th percentile, that K would be 70. So we would go 70 over 100. There are 11 pieces of data, so times 11 plus 1. For 35th percentile, same thing. I would do 35 over 100 times 11 plus 1. So let's do both of those. Okay, so 70 divided by 100 times 12. So that is going to be 8.4. And then 35 times 100, or divided by 100, times 12, 4.2. Okay, so now when these are not even numbers, you're going to look between two values. So for 8 and 4, we're going to look between 8 and 9. So we want the 8th value, so this is between 8 and 9. So let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's 8 and 9. So we want the median of those two values. Okay, so we want 64,500 plus 68,500 divided by 2. So that is going to give us 66,500. That is the 70th percentile. Okay, so the 70th percentile of salaries in that company, 66,500. That's not an actual salary. That's okay. That's saying that that is that range where if you make more than that, you're in the top 30%. If you make less than that, you're in the bottom 70%. So it's just a separator. And then the next one, 4.2, that's between 4 and 5. So we're going to do the same thing. So the fourth value, 40,500. Fifth value, 42,000. So let's find that median. So 40,500 plus 42,000 divided by 2 gives us 41,250. Okay, so that's going to be your 35th percentile. Again, not an actual salary. It's just a separator saying this is the bottom 35%. Above that would be the top 65%. Outliers, let's come back to the outliers. I want to do the percentile rank of those two values first. Okay, so let me get a different color. Okay, so percentile rank of 54,000. So let's find 54,000 right here. Okay, remember percentile rank is this formula. So percentile rank is going to be x plus 0.5 y over n times 100. Okay, so we're using this formula here. So x is how many values are below 54,000. So 1, 2, 3, 4, 5. So 5 values below that. So percentile rank of 54. Okay, so we've got 5 plus 0.5. It only occurs one time. Over, there's 11 observations times 100. Okay, so let's go ahead and do that. So 5 plus 0.5 times 1. There we go. Oh, you know what? 54,000 occurs twice. I'm just looking. I just noticed that. So this would actually be a 2. 54,000 occurs twice. Sorry about that. This is both of these right here. Okay, so 5 plus 0.5 times 2 would be 5 plus 1. And then we are dividing that by 11. And then times 100. So 54.5. I think we're doing one decimal place here. So 54.5%. So that would be the percentile rank. So you're in the 54th percentile if you're making 54,000. And then 40,500 okay, let's see. That is right here. There are 1, 2, 3 values less than that, and it occurs once. So we would go 3 plus 0.5 times 1 over 11 times 100. Okay, so we've got 3.5 divided by 11 times 100. So that would be 31.8. So that would be the 31st.8 percentile for the number 40,500. Okay, and then outliers. So there is an actual test to identify outliers. So you might think 120,000 might be an outlier or 2,000 might be an outlier. Let's take a look. I'm going to erase this so we have some room. Okay, so here is the test that you can do for outliers. It is going to be, or the formula here, quartile 1 minus 1.5 times IQR. That will identify any lower outliers. And then upper outliers, quartile 3 plus 1.5 times the IQR. So if I'm looking for lower outliers, quartile 1 is 33,000. And then minus 1.5 times my interquartile range, 35,500, which we had found up here. So we're just going to go ahead and put that in, see if it works. So 33,000 minus 1.5 times 33,500. So the threshold there would be negative 17,500. 1.5 times 33. I put 33,500. Sorry. 33,000 minus 1.5 times 35,500. So the threshold is negative 20,250. Okay, which means you would have to be earning less than that. Okay, so it's less than or equal to that value to be an outlier. So 2,000 is not an outlier. Okay, then quartile 3 would be, quartile 3 was 68,500 plus 1.5 times 35,500. We would have to be greater than this value. So 68,500 plus 1.5 times 35,500. So we need to be greater than 121,750. So technically here, there are no outliers. Okay, and that would be your test to determine that. Okay, let's take a look at 2.4, box plots. Okay, so we mentioned that previously on box plots. I do have a I do have a tutorial on this. I think I can link to that for you guys. Okay, so a box plot is giving a good graphical image of the concentration of the data. It is composed of 5 values, which we call the 5-number summary. Okay, so that 5-number summary is going to be the minimum, the quartile 1, the median, which is quartile 2, then we're going to do quartile 3, and then the max. So minimum, smallest number, maximum is the largest number. This will not show. Okay, it's going to show the center, the spread, and the skewness of data. All right, so box and whisker plot, box plot, we're going to go through it with this data here. So this is going to be, well, I don't really know what this data would be. We can do this as salaries too, just in thousands. Okay, we got to put this in order first. So let's find the smallest. 69. Then 74. 75. Here, 79. 81. 90. 94. 98. Oop, I missed 84. There we go. And then it was 90, 94, 98. Then 104, 112, 144. Okay, let's see. How many do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 pieces of data. So let's go ahead and find the median. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So my median is going to be in between these two values, between 84 and 90. So median, we will go 84 plus 90 divided by 2. 87. So 87 will be the first thing. Then we want quartile 1. So now with an even piece of data for my quartile 1, I'm going to split it between these two values. Okay, so now I want the median of this bottom piece of data right here. So we're going to go, let's see here, 1, 2, 3, 4, 5, 6. So the 2, 1, 2, 3. 1, 2, 3. So we're going to go in between 75 and 79 for quartile 1, which would be 77. And then I'm going to do the same thing up here. So 1, 2, 3. 1, 2, 3. So between 98 and 104. I think that's 101. Yeah, 1, 2. Yeah, 101 for quartile 3. So 98 plus 104 divided by 2. Okay, so we found quartile 1, quartile 3, and the median, and then we have our min and our max. So that's my 5-number summary. Then I'm going to construct my box plot. All right, so 69 is about right here. So what I'm going to do is I'm going to draw a line right here at 69 for the minimum. Okay, then quartile 1 is 77. So 75, 76, 77, about right here. I'm drawing another line. Then my median is 87. So that's going to be about right here. Maybe a little bit further to the right, but quartile 3 is 101. And then my highest number is 144. So that's about right there. Okay, so here's what you're going to do. You're going to put a box around the middle 3 values to showcase your interquartile range. Okay, so your box looks like this. Then you're just going to draw a line from the end of the box to the other 2 values. So that's your box and your whisker. These are your whiskers on the end. So this shows the interquartile range. It shows that the median is slightly towards the left value, and this is also skewed to the left. Okay, because most of the values are falling right here in this box. And then you might have an outlier with this being out here. So that's what that's showing you. Now you can get these values in your calculator. So let's go over that real quick. So in the first part of chapter 1, we went over how to put a list in your calculator. So that's what you're doing. So we're going to put this into a list. So I'm going to go Stat, Edit, and then there's something in here. So I am going to go over to L1, go up, clear, and hit Enter. to clear that out. So I just want L1. I don't have to clear everything. You can if you want. But I'm going to go over to L1. I'm going to start entering these values. So you don't have to enter them in order too. We could do it the way it was originally here. So 75, let's see here, 69, 84, 112, 74, 104, 81, 90. What happened to my paper? There it is. Okay, 90, 94, 144, 79, 98. Okay, so I've got my 12 pieces of data in here. And then I'm going to go back to my home screen. So I'm going to go second quit. Let me see if I can make this a little bigger. Second quit. Okay, then we're going to go to stat. We're going to go over to calc. And we want to calculate our one variable statistics. So we're going to hit enter. And then the list I want to do is L1. Frequency list, I'm going to leave blank. And I'm going to hit calculate. And I've got all this fun stuff, which we're going to learn that shortly. Okay, but scroll down. Look at that. There's your 5-number summary. Minimum, 69. Quartile 1, 77. Median, 87. Quartile 3, 101. Max, 104. There's your 5-number summary. Now, there is also a way you can do the box plot in here, which I do have a separate tutorial for. I think off the top of my head, if I go to second wide stat plot, I have to turn a plot on. So go to on, and then we want the type. We're going to go over here. This 4th one here, that's a box plot. So hit enter. And then, yeah, I think that's it. So X list is L1, frequency 1, color blue, enter. And then we're going to go to the graph. Oh, there's something in my y equals. Hold on. I have to clear that out. So if there's anything in y, you got to clear that out. Okay, now we'll go back. And then I can't see anything, so I need to zoom stat. So go to zoom 9 for zoom stat. So you can see that. There it is. There's your box plot. Okay, and there's a separate tutorial for this that I'll link on the on your announcement email for you guys so that you can look at that a little more intensely, but you're not going to have to actually do any box plots. You're just going to have to identify this stuff from there. And I think that is everything for 2.4. Yep. All right, moving on.